Hello and welcome to Stats Lab. This quarter we are going to do things a little bit different. Instead of more work with spreadsheets like I do in class, we're going to look at R, the statistical programming language. So the first thing you need to do is get R on your computer, and there's two things we'll need for that. There's the R programming language, which could be used on its own, but we're going to use a special program to integrate with it called RStudio, which just makes it a little bit easier to work with. So first thing, we have to go get and install R, and then pick your operating system here. Unfortunately, if you're a Chromebook user, I'm not sure how to run this in Chromebooks yet. So if you're interested in R and you have a Chromebook, then get in touch with me and I'll help you figure something out. For now, I'm on a Windows computer, so I'm going to go and get R, and I want to install R for the first time. And then there's further instructions here if I need them, but it's pretty straightforward. You just get R, we put it in somewhere like our downloads. You can see I already have it there, but I'll just put it there again. And this exe file, you might get a warning about your computer, from your computer about it, but it is safe. crnrproject.org is a legitimate site. This will not damage your computer in any way. Once it downloads, we'll open it and go through the installation process. So here they talk about the installation. It's pretty straightforward. And we're not going to use their graphical interface. We're going to use the RStudio graphical interface instead. It's a little slow today. Feel free to fast forward through this part. And boom. We open the installer. Choose where it's going to go. The default setting is usually fine. We want all parts of R. Let's see. Do you want to customize the startup options? No, the default options are fine. And we can search for it with R in the setup menu. We don't need a desktop or a quick link, but we want to save it in the registry and associate our data files with the R programming language. Yep, all good, and then bang. It runs the installation. So the default options that it gives you are just fine. And we're almost done. So we need to get R first because RStudio is going to look for R once we run that. All right, got it. Next, we want to install RStudio. And I'm going to install the Windows 10 version. You can pick your version there. And once it's done, click to run it. And just follow the instructions. The default settings are just fine. This one takes a little longer to install. And then finish. And so now we have R and RStudio. So let's open up RStudio. Just search for R by typing R from the Windows menu. I get RStudio as an option there. And here we are in RStudio. And usually there's going to be 4 different windows once you get going. And so we'll see that in just a minute. So it's showing me some files I have access to here. I can load files to work with here. And this is the place where I run certain commands. So there's all kinds of things we can do with R. R is a calculator too. Like I can say, hey, what is 2 plus 3? And R will say, hey, that's 5. But anyway, we want to work with data. So let's go get some data to work with. So there's an R user's guide that accompanies our book. So that would be a good thing to have handy. And so just a little bit of about there. The ideas of an R script. So I'm going to go over some of this stuff in a moment, but this would be good to read through if you're interested in playing with R. What we're going to do next is load data from the textbook. So we want to get the lock5 data package. And I have more information about that in another file down below here. Some instructions to go with R. So let's open that up. And might not be able to view it here. I think we'll have to download it. Oh, they viewed it, cool. So here are some instructions, and this I can actually load right in R. So I'm going to download it and then open it in R. So I advise you to do the same. So just pay attention to where you save it. It's called Intro to R. Save, and then we'll go over to R, and we'll open that file up. So here I want to go to File, and then Open, and then find out where you put it. A bit slow here. There we go. And so it puts it up here. The benefit of having it here is then I can run commands that I see here, and I'll show you a couple of ways to do that. So to get the lock5 data here, the library, what I want to do is go to Tools. So I mentioned that in this line right here. And let's blow this up a little bit. So to install the lock5 package, we're going to go to Tools, Install Packages, lock5 Data. So Tools, Install Package. This gives us a place to search. Then we just type in lock5. And there's a couple of different ones. There's the lock5 Data. That is the one I want here. There's also the lock5 with R, which we may or may not use. That goes with another manual that's related to the book. Install. And so it runs this install packages, just going through some information about what it's trying to do there. So this is the console down here. So when we run certain commands, either from the menus up here or from the R file I have here, it's going to give me information about that over here. All right, so I have that data. So then I could view one of the data sets in there. And those data sets are, again, the same ones that come with our book. So let's take a look at our book for a second. And search for lock5. We should find a link to the lock5 stat website, and then the data sets for our version of the text. So what we just did is we loaded all of these on our computer, all of these data sets here, and we got the R versions of them here. And not only do we put them on the computer, but we told RStudio where they are so we can just grab them when we need them, which is kind of cool. So next time I open R, although R knows where they are, I can specifically tell R to use them by using this command right here. So anytime I have an R script, which is what this is right here, I can just click on a particular line where there's a command and I can click run it, and that will do that for me. So the data actually was already loaded based on the work that happened here. I just did it again. So if I come in tomorrow and I need to work with the lock5 data, first thing I would do is load it by doing the library lock5 data. And then I can get a particular data set, like the all countries data set. So if I just type all countries down here in the command, it's saying, hey, I know some stuff about all countries. And so I can just click it, it'll complete it for me, which is kind of cool. And if I hit enter, it's set to only show the first 40 cases or rows. And then this has multiple columns. What we're going to see is 1 through 40 appear several times here because it couldn't fit all of that data in this screen right here. So I get the first several variables here for cases 1 through 40, and then the next several variables for cases 1 through 40, and the next several. So that's kind of hard to read the whole data set at once, and usually we don't want to look at a whole data set at once anyway. If I want more information about a data set, I can run this command right here, question mark, all countries. So that'll say, hey, what is all countries, by the way? Like, what is electricity or developed mean? And again, I can run that by either copying, pasting it to the command, the console down here, typing it myself, or from this line up here, I can just click the run button. And then over here, it's going to give me some information. So now I can see, oh, okay, so it's data on the countries of the world. This data set has 215 observations. Those are my cases, and there's 25 variables. And then here it tells me a description of what each variable means, which is pretty nice because usually just the short heading title is not all that descriptive. It's just a key to remind me what is this data, but I need a definition of it somewhere. So here's the definitions. If I wanted just a summary of those names, I could use this next command right here, names all countries. So I can click there and just hit run. It'll copy the command down here and run it for me. And the 1, 7, 13, 19, 25 just means here's the first one. It shows 6 of them, and then the 7th one is the CO2. It shows a few more. This 13th one is cells, and so on. So that's what these numbers on the side are referring to there. So these are all the variable names that I have to work with, but question mark all countries tells me what each of those variable names really means, which is nice. If I want to just look at one of those variables, then what we do is we say, okay, what data set do we want? So I want all countries. And then to pick a particular variable, we do $ variable name. So if I run all countries $ rural, then it will only show me the data for that. So notice it grouped them together here, and there's a space between them. Again, looking at the data raw isn't always all that helpful, kind of hard to look at. We probably need to do something else with it to get a better view of it. Other things I could do is I could do a random sample. So for example, all the countries, there's a variable called country, which gives me the country name. I could draw a sample, and let's see, this says there's 215, so I could go 1 to 215. So this says from the variable country, in all countries, take a sample out of the countries 1 to 215, but just give me 10 of them. And so if I run that, it'll just give me 10 randomly ones chosen from these here. And this says there's 216 different levels. So that's interesting. So there's more than I thought there. So maybe there's a slight, this was updated, but the description wasn't. All right, so we're going to play with a different data set next. I'm not quite ready to go over numerical variables. We haven't covered that in class yet, just a tiny bit, but maybe we'll come back to this. Let's take a look at some categorical data, which is more of what we've been talking about at the end of week 1. So I have collected data. There was that survey I asked you all to take about you, and then I have some summaries of students. So I just grabbed the gender variable and the eye color variable, and I put them into a file that R can handle. So let's go to the day 1 page here, and then get the student gender and eye color data. So we'll have to download that and put it somewhere where you'll remember it. And it put a 1 on the end of mine because I already had it there. So I'm just going to get rid of the 1, replace it. I don't need to open it here, I need to open it in R. So then once it's downloaded, I can go over to R. And instead of opening the file like I did here, what I want to do is import it as a data set that I can use down in the console. So in this case, for a data set, we go to import data set, and then the first option from text, and then we just go find that file. Student age. Or sorry, student GE, gender, eye color, GE. That's my abbreviation there. And then it gives you some information about it and some settings that you could decide to change or not. So it recognized that these were comma separated. This is what's called a CSV, comma separated values file. So this is what R is getting, and then this is what it's going to output. So it's bolding gender as the name of this column, this variable, and then I, no space, capital color, is the name of this column of data right here. So this is what I'm getting in. Usually we don't have to change that. NA string, so NA means not available. So that means there must be, well, there often is in data where you for a particular case, you don't have a value, right? It wasn't available somehow. So this says it's going to replace any blanks with an NA. That's okay. Sometimes instead of NA, I use a null for blank. I mentioned that in class the other day. Something just for fun, I'll change that to null. And then usually you don't have to do anything there, just import it. All right, and then it's going to show me a pretty preview of it. Looks like a spreadsheet version of it, like I would see in an actual spreadsheet. It's telling me there's 2 variables and 122 observations there, and then I can play around with it. So I'm going to switch back over here to my intro to R page, which shows some things I can do with that. So once I've entered that data set, so I did the import data set here, which is what my first line of the instructions asked me to do. I can do something like make a summary table. So we're going to get a summary table of both categories in a 2-way table. And so all I have to do is run the command summary. And then again, what does this mean right here? So this says find the data set called student GE. And then in there, there's a column or variable called gender. And variable columns in R are also known as vectors. And so I can show you some more about vectors later, but a vector is a column in a data set. It's the values of a particular variable. So let's run this command, see what we get. So it summarized them down here for me. So I have a blank 0 or 1. So that means there were no females that didn't give me an eye color, but there was 1 male that didn't give me an eye color. And then I can see there were 21 female blues and 12 male blues, blue-green. 2 females said that, 2 males said that, brown, most common, 35 and 10, gray, 1 female, no males, green, 18 females, 1 male, that's interesting, hazel, 16 females, 3 males. So there's a summary table. Sometimes instead, I just want one of the variables summarized, like I want to just see what's going on with gender or what's going on with just eye color instead of a 2-way table here. And so I'm just going to show you a couple of tricks. So in this line 22 up here above, I have gender and then a backwards arrow, student GE gender. Now I'm just going to do a couple things here just to show what's going on up there. If I just start typing student, the R should realize, hey, you've got some things called student. It recognizes from the imported R data, sorry, the imported lock5 data that there is a survey, student survey data. That was referenced in the book several times. And then it says I have another data set called student GE. So I can either hit tab to complete that or I could have clicked on it. So student GE is all of this right here. And then in student GE, I can do $, just click down here, $, and start typing. If you start typing something, it doesn't pop up anything here. That means you're typing something the computer doesn't recognize and weird shit's gonna happen. Like if I try to do a lowercase g for gender, I think it's going to be confused. Oh, wow. Oh, it changed it for me to an uppercase. That was very sweet of it. It is case sensitive, right? So if you do throw uppercases in places where it doesn't expect them, you'll get some weird shit. So it's showing me all of them. What I'm going to do instead is I'm going to take all of those gender data and I'm going to store it in a new place. So I'm going to make a new variable called gender. That gender is going to get filled with, that's what this arrow means, fill this thing called gender with the student's GE gender variable. So right now, all the genders are located in this data table in this column. Now I'm making a new thing called gender, and gender is going to have just those genders, nothing else. And then I can make a table of that. So if I do table gender, enter, it will say, hey, okay, here's your gender table. There were 93 females and 29 males. Alternatively, I didn't have to do that store it in gender. I could have just made the table. If you hit up arrow, by the way, it brings up previous things you typed. So I could have just done this. Table, student GE, grab the genders, and it does exactly the same thing. Except I don't get this header, which is the name of my variable. So we're just kind of playing around with what R can do with data. And the nice thing that about R that's a little different than a spreadsheet is I can write these scripts to make stuff happen. And if I want to do similar things to other data, I can reuse a lot of this to make it more easily repeatable than in a spreadsheet, which is kind of nice. So the next thing I want to do is I want to get some relative frequencies on the gender. So to do that, I'm jumping down to this next line here. Oh, by the way, in addition to table, there's another command called summary, which does pretty much the same thing as table. All right, so what I'm going to do is to that variable gender I had, again, you could just click up here and hit run, but I'm just going to retype it, explain what I'm doing. I'm adding on a feature to that, so kind of like a new column. Yeah, sort of like a new column. And I'm going to call that feature rel freq for relative frequency. And then instead of the whole arrow thing, we can do an equals, which behaves like that backwards arrow. And then what I want to do there is I want to have it count up all of the genders. So, oops, I'm missing a step there. Let's back up. I need to calculate those frequencies first. So I missed that step. Gender frequency needs to be calculated first, and that is going to come from the table of gender. So I need those counts, the 93 and the 29, because then next, once I have those stored, I can divide by the total number of cases. So gender frequency needs to be defined first, and that's going to just be the table of gender values right here. So when we do this equal sign, that just stores it for us for reuse. If we just run it without the equal sign, then all it does is display it and forgets about it. So these variable names are to remember and reuse calculations we make. Okay, so now I can run this command up here. So I'm going to make a new gender relative frequency. And that's going to come from gender frequencies divided by the number of rows n row, and spaces are just there for humans to read it. So I can run this with or without spaces. I like the spaces so I can easily read it. And it's going to get that from the original data set, student GE. So what's going to happen here, so right now I just stored this table of data in gender frequency. Next thing I'm going to do is I'm going to make a new thing to remember, relative frequencies, and that's going to be the numbers in this table divided by the total number of rows, which up here is 122. Now, I could just type 122, but it's better to have R double check that that really is the count there, so that we don't mistype something. All right, so I got it now. So then if I say, okay, what's in gender dot frequency, first one I did, it's just going to show me that table again. If I ask what's in gender rel frequency, it's going to give me the 93 out of 122 as a decimal, the 29 out of 122 as a decimal. So now I get the relative frequencies. So I can say what percent of males, what percent of the class in the survey were males, and I could say it's about 23.8% there. So I can get these numerical tables just like I can in a spreadsheet. It's a little harder to change the frequencies to a relative frequency table on a spreadsheet, but it's doable. But often, again, a table of numbers. So I think this summary count right there is better than looking at the data table right here, right? And these percentages are helpful too. It's nice to know that there's about 76% of females instead of just 93 versus 29. But it'd be nice to have a graph of this. So we can make graphs of these things. So I have some instructions back here about graphs. A bar plot is something I could make. Now this one's going to make a bar plot for the whole data set, gender and eye color. Let's just make one for the genders. So if I just type bar plot, kind of like I have above, it says, hey, yeah, I know bar plot. Okay? And then it gives me a little information there. If I wanted more information, I could just press F1, and then it'll tell me about how to enter bar plots and all of the different features the bar plot has. So kind of like when I'm in a spreadsheet and I say, hey, make me a bar chart Excel or make me a bar chart Google Sheets, it has all these things I can change about it on the side, which I demonstrated in the class. In R, we just type the thing we want to do. So I'll just do a couple of examples of this. And there's a bunch of guides I have with more description. But the help files here, once you get used to reading them, are pretty useful because they give all kinds of descriptions of what the different aspects of the chart are. All right, so the easiest thing you can do is just type bar plot and then give it something to plot. So I'm going to do bar plot of gender relative frequency. Maybe we can just tab or click once it gives us an option. So if I hit that, then it's going to load that over here in the side. So that's the first view of it, and it gives me this numerical scale over there. Up arrow, if I go back to the console, I could do just a bar chart of frequency. And so there's the bar chart of frequency there. Now the default is gray. I could add some colors. And so I have an example of adding colors here. Now I don't need a legend in this case because it's just female and male. It's pretty straightforward. But another example I will. So I'm just going to steal this part right here. And I'll explain that. Actually, I'll retype it and explain it. So let's do the bar plot of relative frequencies. So if I want to add extra things about how to describe the bar plot, then I do a comma and then tell it what to do. So COL stands for color or colors. And then if you have more than one color to put in there, then you have to use what's called a vector, which is the letter C, and then you need another parentheses. And R will automatically put the closing parentheses next to help us not screw up where parentheses start and end. Important thing in math too. And then let's say I want the color red for one of them and the color blue for the other. And I'm pretty sure the quotations there are necessary. Let's hit enter to run it. And so now I have red and blue for the colors there. Usually we want titles too. So the first thing you do in bar plot is you tell it, okay, what data do you want to plot? Next thing you usually do is you put a main title that's just called main. So comma main equals quotes. So this would be student survey genders. So just some kind of title. After the quote, I need a comma. So then it says colors next. So that puts that up at the top there, which is kind of nice. All right, so example of bar plot. We could do a pie chart too. Let's see, I haven't done a pie chart in a while. All right, I gotta look up how to do a pie. We'll come back to that. Let's run the one on the whole data set. So notice here I was calling gender relative frequency, which was this table of numbers here. So when you do a bar plot, it expects a table of numbers. So if I don't already have a table stored somewhere like I did in gender relative frequency, then I have to make it on the fly. So that's what's going on up here in this command. This says, okay, make a bar plot of the table of student GE. And the table of student GE was back here, that's this. I don't have that stored in a variable. Notice I just made the table without storing it somewhere. So I have to make the table before the bar plot. And the order of operations here, right, is to do inside the parentheses first. So it looks inside the parentheses for student GE, and it makes a table of that, and then the bar plot gets to make the bar plot of the table. So let's just run this and see what happens. Sorry, my Zoom menu is in the way. Put you there, run. The default for a bar chart of more than one variable is to stack them. And it put a legend up here for me. I had legend true there. Without that, it wouldn't have the legend, which then I have to wonder what color is what. And I put the colors in, otherwise it just shades of gray if I didn't do that. So if I ran this without the color, well, get rid of the extra comma, close the parentheses, enter, it just shades of gray. If you forget parentheses, by the way, then it puts this plus down here saying, hey, you forgot something, and question mark, oh, parentheses, and then it'll run it. All right, so not as pretty as the color here. Let's see. No. Oops. Let's put the colors back in. If you don't like the stacked version, which is a nice comparison, the book goes over a stacked version of something like this for two categorical variables, you could have them side by side. So that was this next command that I have right here. So if I run that one, it puts them side by side instead of stacked. And so you can decide which one you want. Now, one cool thing about R, when you make these graphs right here, if you right click on them, you can save them or copy them and then put them somewhere like, say, a Google Sheet. So I could copy this image right here, and then I could go over to my Google Drive, and then I could add a new, come on, wake up Google, there we go, new Google Doc, and then I could just paste that in here. It catches up. Or I could save it to use it somewhere, like submit it in Canvas. All right, so what's missing here? Oh, I'm missing some titles here. And so back in help, let's see, I had bar plots. So let's get some titles in here. So we played with some titles earlier, so let's bring that back up. The main title is one you should always have. So right after you say, here's my data for the table, you should do main. I'm just gonna put main comma for a second, and then back to main, it's always equals quotes, and then whatever your title is gonna be. So this would be something like student survey, gender versus eye color. Just hit enter, it'll run that. So now I have a title at the top. I think it's pretty obvious that these are eye colors down here, but we could always add that. And then the numbers here I think are pretty obvious, but we could always add to that too. So if we're not sure how to do something, then we try to look at the help page and see if we can figure it out there. So I am looking for something about titles here. Okay, or labels, there we go. So we have a thing called XLAB, XLAB, X for the label on the x-axis, and then we have a label on the y-axis. We also have the limits here, so if we wanted the axis to go up higher or lower, we can play around with those limits also. And then sometimes when I look at these, I'm not sure what they mean, so I'll often do a search to see if I can find out more information, like limits. How do they want me to type those limits anyway? I'm not really sure. So I could just go and search for that. R charts, maybe, and then hopefully I can find someone that says how to do it. Basic R chart. R bar chart customization, maybe this one. Stack Overflow is a place I go to a lot where people ask questions and other people answer it. Cool thing about that is there's usually multiple different answers about that. So then I could look down and see what kinds of options people gave me for how to answer those. Let's see, they have a Y limit here, and since there's multiple numbers, it has to be as a vector, which is that C notation. Then they have some examples of it. Oh, that's cute. They did a nice job. And generally, when I go there, they show me other stuff I didn't know about. Like, man, I want that rainbow effect there. How did they do that? So I could try that right there. I wanted to. All right, so let's go back to R and try to put in some labels. And often I just add the labels to the end. So the last thing I typed was besides true, and then before the parentheses ends down here at the bottom, I would do comma, X LAB, and it says, yeah, we know X labels, so I could hit tab or just click on it, and then usually want quotes. It puts spaces in between the names and the equals, which is fine. You can have spaces or not. And so the label X label would be the eye color. And then I want the Y label too. Those usually have to type a few letters before it recognizes it. And then I would just type something like number of students. We could call it frequency, but again, if we're displaying this for other people that aren't in a stats class, like my mom, she'd look at the number of frequency and she's like, frequency of what? Well, number of students. Oh, why didn't you just say number of students? Oh, right, okay. So you may be looking at this and like he's thinking, oh, typing this stuff is just a pain in the ass. But the nice thing about it is I can reuse this. So somebody says, okay, here's some other data set. I want something similar for that. So I could just reuse this code right here for any data set I want. I just have to tweak the titles. But if I have a color scheme that I like, if I have labels in the right spot, if I have a legend, if I want them side by side, all of that's in one location. So I can just quickly get to it. Whereas in a spreadsheet, I got to go here and click and there and click and here and click and there and click. It's a lot more work. So the thing people like about programming languages like R is you can have a script that you just reuse over and over again, which is kind of nice. And the variables allow us to make that happen quicker too, which we'll get into later if we continue with this. All right, I think that's pretty good for today. Yeah, so a little bit introduction, how to get R, loading a data set, some things we can do with categorical variables. Next time we'll look at what to do with quantitative variables like make a histogram, which is a huge focus next week, and calculating things like average and standard deviation in R. Thanks for playing. That's all for now. Adios.